Hi, this is the review, the quiz review for your quiz. Check your understanding, Unit 1, Lesson 2, Investigation 2. All right, so let's get started. Okay, the instructions state to please be sure to use your notes and a calculator in order to complete the quiz. So I think it was pages, I don't know, like 43 to 45, something like that. We did numbers 1 through 7. So these questions will definitely help you to complete this quiz. So have that information out. Okay, if you feel you did not do well, you may retake the quiz up to 5 times in order to get the best possible score. So if you feel, oh man, I messed up, I can do better, then definitely retake this quiz. Okay. So in the previous lesson, provided the following information about an outbreak of measles in Colorado. Of 609 children who had been vaccinated, 10 got the measles. And those 10 had been given only one of the 2 recommended doses. That's kind of like irrelevant. That's why it's in parentheses. And then it says, of 16 children who were not vaccinated, 7 got the measles. So we're going to fill in the table of observed frequencies for this situation. As usual, the explanatory variable defines the columns and the response variable defines the rows. Okay, so here we have these 2 guys right here are the columns, so this should be our explanatory variables. And then here, our rows are going to be our response variables. And I remember that my response variables is kind of either the unwanted situation or wanted, something that we're trying to see that the unwanted situation, something we didn't want to happen. So what is it that's happening here that we don't want to get or we don't want to happen? Okay, so for example, maybe our unwanted situation is getting the measles. We don't want to get the measles, right? That would be not good. Okay, and what explains whether or not you get the measles or not get the measles? Well, it's either, let's pretend this one is getting vaccinated will explain to me whether or not I get the measles or not get the measles. All right, and this is it. This is, now you just have this information. It says of 609 children who had been vaccinated. So here's vaccinated. So the total here should be 609. Okay, of these children, 10 got the measles. So here I should have 10 for getting the measles. So when I add these 2 numbers together, they should equal 609. So what should this number be? 10 plus what number gives me 609? Okay, then you fill in this side of the table. What is the other explanatory variable? How many of those got the measles? So here is our information. Remember, of 16 children, just like here, of 609 went here. Where are we going to put the 16? If it says of, that's kind of like our total. Okay? And 7 got the measles. Oops. Okay, so let's move on to the next problem, number 2. That's it. And then each of these is going to be used, your answer choices should only be used once. So there should be no double answers. Okay, so now we're going to fill in a table to find our expected frequencies for the same situation. All right, so the first thing I do is I have to put in our totals. All right, so here I know I had 609, and what was the other total? Whatever total this was, which should have been, okay, 16. And when I add 106 and 16 together, that should give me 625. So we're trying to find out what goes in these boxes. Okay, and we know that when we find our expected frequencies, that's going to give me a homogeneous kind of sample. All right, so first we need to find the proportions to help us fill in these missing cells, okay? In other words, let's see, how many total people or children got the measles? I want to know how many total children got the measles. Well, your question would be, well, I don't know these numbers yet. That's what I'm trying to find. Yeah, but we know the totals because you know that 10 vaccinated got the measles and this many, were not vaccinated, got the measles. For example, here it says 7, so it's probably a 7. All right, if I add those two numbers together, that's going to give me 17. So this number should be 17. Okay, and then I can fill in this number now because I know that 17 plus this number here should give me 625, or I can go up here and add these two numbers, and that is another way to get, so if I add this number and this number, because this is going to be didn't get the measles, those two numbers added together will give me this number here. Or like I said, 17 plus what number is going to give me 625. All right, so now that we have our marginal totals, we need that proportion. So let's see. So we need the proportions. We have all our totals set up already. Got it, got it, got it. So now to get those proportions, this is 17 divided by 625, and this is whatever this number is divided by 625. And once I get this proportion, so this proportion times this total, so it's kind of like it lines up, right? Multiplication table. So this number times this total is going to give me this answer here. Okay, then, let me erase all this stuff. Okay, then this number here times this total goes here. Okay. That's all I'm going to keep doing. Okay, let me do a dark. Actually, that's going to match too much. I'll do this dark color. Okay, and then this proportion, whatever I got here, times this total here. I multiply those two numbers, gives me that expected value. And then this proportion times this total will give me this expected value. Okay? And once you find your answers, check down here to find if you did it correctly and fill it in. So let's pretend like this one was 0.4. That's what I would pick down here and click and drag your response to the correct place. All right, so now we have to compute those expected. We have to compute our chi-squared using our observed and expected frequencies from problems 1 and 2. Okay, so I know, okay, I have to do O minus E squared divided by E for each one. So here I have 10. I'm going to do 10 minus whatever number I had here. Okay. So I'm going to pretend this number is, I don't know, 16.6. Okay. So then it's going to be, I'm going to do that for each one. 10 minus 16.6 squared, and then I divide by the E, and the E again was, remember, E is our expected, the number here. Okay, 16.6. Now I'm going to do then I'm going to do the same thing for each cell. Plus, so I'm going to look at a number that I have here. So then this number minus this number squared. And I'm going to square it, then I'm going to divide it by 0.4, and I'm going to add it to, so that you should have 4 of these. 1, 2, because there's 4 cells that I'm working with here. 1, 2, 3, 4, and remember they match. This one goes first. 10 minus 16.6 squared, then divided by 16.6. O minus e squared divided by e. And I'm going to do that, okay? And that's going to give me a chi-square number. Okay, and you're going to write that number in. Number is, I don't know, whatever it is. Something, point, something. Round to the nearest place. So whatever your numbers are, point, this is the thousandths place. Okay, so is your chi-square close to 0 or does it seem large? Explain what the value chi-square tells you about the two samples. So you need to use the word homogeneous. Remember, the larger the number, it's not going to be homogeneous. And the closer to 0 your chi-square is, it is, I guess you could say, homogeneous. All right, and then the last one is which is the following, or which of the following gives a formula for the chi-square statistic? So you pick the correct one. And this was actually one of our problems that we did in class. You turned it in, I graded it. So if you didn't get it right, I circled the correct one. Or you could look it up. Which is the correct formula for the chi-square statistic? And that's it. That was question 5, and that's all of them. Remember, if you need help, come to office hours. If you still need a little bit more clarification. All right, bye.